This video is the last part of my digital guitar pedal building course. In this final episode, I'll give you some tips and tricks on how to solder together all your parts onto your custom B that hopefully have been delivered to you by now. By the end of this, you will hopefully have a custom built guitar pedal, or hopefully just the knowledge so someday you can go and make your own. Hope you enjoyed this course. This took a while to make, but I find that a lot of this knowledge is hard for people who know a lot of things, but they just can't really piece it together. And it took me a while when I started off to really get to this point. So hopefully I can just pass on that knowledge. If you learned something or enjoyed, a subscribe would be great. I'm a pretty new channel, so anything helps. Once again, thank you to PCBWay for sponsoring this course. In this video, I'm gonna go more over some stuff I did through PCBWay and show you how you can use some of their custom CNC services to make even cooler pedals than what we did in this course. Great job getting this far. Hope you enjoy this last episode. Thanks. We did it. We got all of our parts ordered, made, built, shipped to us, and now we are ready to put it together. So really the last remaining thing is to solder it all. So if you already know how to solder, which I kind of assume a lot of you do, don't worry, I'm not teaching in this video how to solder because honestly there are already so many resources out there that anything I'm going to say is basically redundant. So if you literally have never soldered before, I recommend to just Google and find any YouTube video teaching you. What we're doing is pretty simple, minimal through-hole soldering, so there's not going to be this big learning curve. It's pretty simple, even though it might seem daunting with lead and high heats and everything. You're not going to hurt yourself. It's fine. Make sure you have good airflow and you'll be good. I do have the first soldering iron I ever bought. It was like 20 bucks. I think some of those, if you're like totally just getting started, are totally fine. You don't have to go spend 100 bucks. I have a slightly better one now. But if you're seriously just starting out, don't go spending a ton of money. So instead with this video, I'm going to give you just some tips for soldering together the pedals specifically, and then sort of some going forward tips. As we know, this course was sponsored by PCBWay, which earlier we ordered our PCB from. But on top of that, I also wanted to show you how using their custom CNC machining, we can make even a cooler custom pedal that will cost a lot more money than doing something like Tata, but then you can make your own completely custom shapes, and it's pretty awesome. So in this video, I'm going to show you just pretty quickly some of my process for making this custom pedal. It's not like a super custom shape. I just did the 1590B kind of standard size, but it's a smaller pedal. So I wanted to show you how we could maybe make PCBs for scaling down to smaller sizes or anything, just to give you some ideas going forward. But I'm going to do it a little backwards since you might be at the point where you're just ready to solder. So here are just some basic tips for you if you're going to solder your pedal right now. So here's most of my tools here for the pedal. We got our soldering iron. This is the TS101, I believe, from the company Miniware. I got some helping hands, steel wool. We got our little sponge under here, and then I have the pedal totally soldered. So I have already done this, but I'll still show you tips using this new one I have. And then I got the daisy right here, headers. This is the enclosure I got custom CNC'd. I'll give you the story on that soon. And then here's the PCB I will be using for this pedal right here. So in terms of all the tools you will like totally need for this, obviously you need your soldering iron with your sponge, steel wool for cleaning the tip. I would say helping hands are pretty required, maybe not this one exactly. These are super cheap. You can get these anywhere, but just any sort of way to sort of prop up things. I'll give you a little tip on soldering some of the jacks and stuff. But yeah, some way to obviously hold the PCB while you solder things on. In addition to that, you'll see that we actually have wires in here. So these jacks and the foot switch are all actually wired into the PCB. So I do have a big thing of stranded wire and solid wire. The difference is the stranded wire will be much more flimsy and bendable because it's just a ton of little wires in there, while the solid one is like more like those jumper cables we had where they're just one little more solid wire. Stranded would be better for this because we want to be able to squish it and push it down and fit it in a smaller space. So I do recommend stranded. They're a little bit more annoying starting off because you will need to sort of make sure the tip can actually fit in the holes, and it's sort of annoying, but it will be better overall so we can squish it, especially since there are some wires under the daisy itself in this design. Because we're working with wires, wire strippers are very helpful. You can use scissors or wire cutters to strip the wire. I don't totally recommend it, especially with stranded wire. You might cut some of the little wires off. So I just have these wire strippers right here, very standard. You can choose the size. These also have wire cutters in them, so I don't need both, but I do have my own pair of wire cutters. I got the daisy right here. I got some headers I'm gonna use that are smaller than the ones you might have. These ones are sort of low profile headers. The point is for this pretty small pedal, I need to be able to really fit it in there, whereas these ones have the bigger headers so I can put wires under there. So it's just different designs. So first tip I want to just give is if you bought the unsoldered daisy like I did, I really recommend that when you solder on your headers, you don't just put them in like this and then set it down like that and then solder on that, because you'll find that you can make these headers uneven because you'll see they're really wobbly and you don't want to have them bent in any sort of way. So the best way to do this would be to just get your breadboard and actually just stick it in there. You could also just put your headers down and do that too. So now when I solder this, I know that the spacing is already perfect and it can't really move around that much because it's in the breadboard itself. So here I am, I got my defumigator on, soldering iron, which is heated up. I have this nice little 3D print here so that I can just nicely pull solder. Got the solder on there. Got the daisy. And one little tip I'll give if you're starting off, just because for some reason I didn't realize this until later, your sponge should not be dripping wet, and it definitely shouldn't be dry. I don't know why this took me a while. I used to just like wet it a ton and then just put it down, but you should wet it and then wring it out, and then that will be perfect. So it should not be dripping water, but it definitely should not be dry. So now I'm ready to solder this together. So there we go. I put all the low profile headers on here and it's looking good. I can take that off and it is perfect. So next step is to solder all of our parts, obviously. And there is an order that you should do this stuff in that will just cause the least amount of headache. Kind of some of the rules I guess I follow are to try and do whatever is lowest first to highest, like in terms of the actual height of the component. You'll find that that'll create the least amount of headaches, because if you have some part that is towering over and you're trying to solder something that is smaller, it'll be annoying to try and fit your soldering iron in there, and you don't want to accidentally touch anything or burn it. Another general rule when you put the daisy in and you solder your headers, we do want to do the same trick as earlier when we soldered the daisy, where we actually should put our headers in. So I don't have any 20 pin ones lying around, but here's a 40 pin and I could cut this. And I would want to actually put these in there with the daisy seated on top before I solder it in. That's kind of another thing just to make sure our headers are straight. So here I would take this header and put it on, and this other one, and then instead of just soldering that like that wibbly wobbly, I would want to put the daisy on and then solder that. So that's something to keep note. And also, if you're just wondering the point of the headers, the point is that if the daisy craps itself, or if we just want to move it to a different pedal, then we can, since a $30 component is cheap for the daisy, but actually pretty expensive relative to the other parts. So if something happens with it, we want to be able to easily pop it out instead of desoldering 40 pins. That would be very obnoxious. So it's just a nice kind of fail safe. And honestly, like once you have more pedals, I'm constantly kind of moving daisies around to test things so I don't have to constantly rebuy daisies. But yeah, first thing I would recommend something like the resistor. That is an easy first off one. Another thing you'll notice is I do have this capacitor here, which I didn't show in the course. I was kind of Googling around about easy ways to have a little bit less noise. And I read online, somebody said putting a 1000 microfarad capacitor would reduce noise by like 50%. And when I tested that in a DAW, I found that that was true. So now I kind of just always do that on my really basic builds. The ones that I don't want to put much more else, I just throw that there. I didn't teach that here. You can kind of Google that for yourself, and they're pretty easy to just add on to your PCB. But yeah, I would definitely just solder the resistor on here first. And I typically do all the wires at the exact same time, just because that is a somewhat different workflow. So it's nice to just do that all at once. Another big thing to remember before soldering anything is the actual orientation of which side you're soldering which parts on, because they are different. With this example of the pedal I made during the course, everything is soldered on the one side except the pots, which are soldered on this side. So the side here that we're kind of looking at on KiCad, that's the side I actually solder on certain things like the LEDs. The pots, it seems here, I also just did the foot switch on that side. It doesn't totally matter. You can solder on either side. That's part of the point of through hole in this. But yeah, you need to note that, because like obviously if I accidentally soldered the daisy on the other side before looking at it, then it would not fit at all, which is different. Something like this pedal, I actually do have the daisy facing that way. So I'm going to solder the daisy pins here. The daisy will be facing this front face. So it is the opposite of that one. So you want to really pay attention to these things, because desoldering kind of sucks, and I don't recommend that you reach that point. So make sure you double check everything. So here we are. I placed the three sort of smallest components here, and then on the other side, this is typically what you do. is I just bend back the pins so that they stay in, and then I can come here and clip that into my helping hand and solder that. One little tip I'm going to give for people who are new to soldering and might avoid is if you learn about flux in videos, but it seems a bit complicated, and then you learn that there is solder like this solder right here, which has a rosin core, meaning it has flux in it. I honestly do recommend starting off that you just get a flux syringe or get more, because it honestly makes soldering so much easier. But I'm a bit hypocritical saying that because I have actually ran out of my flux, so I don't have any here to use today. But I think it makes soldering starting off a lot easier, which is kind of ironic because I feel like a lot of times beginners avoid it because it just seems like one extra step. But I think it just makes your solder joints just work a lot better. So I recommend that even in combo with the rosin core. Rosin core doesn't completely replace flux, but it will like do the job. Like I'll be able to solder these all together. But yeah, I recommend just looking into it. It's cheap. You can get it right on Amazon. So yeah. So there we go, I soldered it together, and forgot to mention that beforehand I did get open on my computer over there KiCad and my 3D model of this, just as another way to double check, since I had done all of that triple checking when I made this. It's a good way to make sure you're soldering it right, is to just refer to that. If you have bigger parts, you will obviously need just bigger sheets written out with these sort of keys. So like here, that was C2 and C1, and I gotta say, okay, which one is that? Pretty obvious here, because one is radial and one is a disc one. But if you have a ton of parts, you will need to go and look and see which ones you actually need to solder, especially like resistor values or something. But hopefully that's pretty self-explanatory. Now I'm just going to snip off these pins. So next, I think I'm gonna put the headers in, because this pedal has really tight clearance. Pretty much on the 3D model, the pots are like overlapping with the daisy, but it was just so little that I'm really hoping it'll actually still work. I still don't really know, but I'm hoping for it. So I got to do the daisy first before I solder any pots or anything, because I want to make sure I can squeeze it in there. So I'm going to do that little header trick, making sure to note the orientation to actually solder it onto. So here I got the daisy with the headers in there. And another trick here, because now these are not soldered in yet, but I need to, and one trick is you can just get like styrofoam and then just like push it into it. Something like with the daisy, I might take this little cap off so the pins will actually stick in there. I don't have any styrofoam right now, but I do find that I can also just pretty much set it down like that. Maybe hook up one little helping hand to stabilize it, but I can feel that all the pins are not moving around and they're very even, so that like should be good enough. All right, I got the headers for the daisy soldered on there. And now for the rest of the build, I do recommend just taking it off because you don't want to accidentally hit it or anything. But yeah, now we can move on to the pots. So first thing you're going to want to do when you get your pots is notice this little tab on the left or right of your pot. Zoom in. So you see this little tab right here. This is for locking pots in place. It's actually a very handy feature, but with our enclosure and the way we did this, we did not utilize this. So we actually need to take some wire cutters and cut it right off. Now I could just go here and push really tight, but this piece sometimes just goes completely flying. So I like to just like put it under something. So here I'm gonna put it under there, squeeze tight. It still went flying. So maybe put it in a bigger thing. But yeah, we do need to snip all of those off of our pots. So my big tip for the potentiometers is we want to actually put them in the holes before we solder on. First, you want to see the actual orientation. Like here in this one, they're sticking up, but these are actually like backwards. So this is the way that this pedal is going to go in here, and you see the pots are pointing down. The one that we made throughout the course is the opposite. So these would be pointing this way. You can do it either way, obviously. It's just all depending on how you're going to fit it in there. But for this pedal, I had to do it this way, which means in the code, I'm going to have to invert everything. But yeah, then we want to actually put it in the holes. But you might notice it would be really annoying for me to put it in here, because then we're going to fight with the walls of the enclosure. So I typically just put it on the face, and I can pop that in. And now I have the perfect surface for me to solder on all these pots. It will definitely fit because they are already fitted. And yeah, it's a very handy way to do things. All right, once you've done that, we can pretty much do the exact same thing for the LED. You just really need to make note of which leg is which. Typically with LEDs, the short leg is the cathode, which means that's what goes to ground, and it's also the side with the flat side of it. So I can just put the LED in with the correct orientation, pop all that in, and then I gotta make sure everything's flush. I actually went and put the daisy in because in this build, the daisy is just a little bit taller than the pots, which will create some annoyances, but either way, I want to make sure my LED is coordinated with that. So there it is. I have just a little bit to solder on, but it should be fine, I think, in the end. So I'm going to solder that on right now. All right, so there is the somewhat easier part done before the wires. This has actually ended up working out. I had mentioned that some of the clearances on Fusion 360 were a bit odd here, so you can kind of see they're a little crooked, but it was as I hoped, and it did kind of just push over. I also accidentally soldered a knob with a slightly different shaft than these, which is fine. I don't really care to desolder it. I have caps for that. It'll just look a little bit different, but yes, it's coming out well. And at this point, you could just check to make sure everything fits correctly in the actual housing. So you could kind of pop that in, and there we go. And now everything is good there. You might have to kind of finagle the pots a lot of the time, but it should work at this point before we do any of the wires. So before we do all the wires, meaning the 2 jacks, the DC jack, and the foot switch, there is an annoying thing about the DC jack that you will need to know. You'll see here, if you look at the DC jack that I use and linked down below, the actual screw for it is on the inside, which means that to actually screw this onto the housing, we had to have it in and then screw it, which if you think about that means that we have to have the wires already soldered onto the PCB once we put the jack in there. It's very annoying. There are many ways around this. The main one that I do a lot of the time are screw terminals. Here's an example of a screw terminal right here. So instead of directly soldering on the actual wires, you just stick them in there after crimping them in this certain way. And so if I wanted to, I could unscrew these right here and pull those out and then take the PCB out. So this is something that you just put another different footprint on, but for this pedal, it couldn't fit, sadly. The screw terminal was a bit too high for having it on the back side of here when I put it in, which was unfortunate. And then I decided not to teach it in the course just because it was kind of one extra tool you need. Like here, I have this tool for the screw terminals and then a whole little pack of things. And I wanted stuff to kind of be the least complex as possible, which does mean that there's this annoyance of having to get your stuff wired on before you actually fit it. And so yeah, what I typically do then to kind of compensate for that is I put on like pretty long wires for the jack, not crazy long. And also for this being power, you don't want it to be like way too long, but I just put it long enough so that I could maybe have the PCB sitting out from it just a little bit. In the case of this design, I have the power jacks all the way up there, like the holes for it. So I'll need the wires to at least be that big, and then I might add on like 50% of that or even double sometimes because I have plenty of space here to fit the wires in. And yeah, it's not a huge deal, but you will need to make sure that the wires come from here, go through the hole, and then go to your PCB. This has to do with like grounding stuff and everything. You can't have the metal from the DC jack just directly on here and touching that. So yeah, it's a simple problem. So next we're gonna have to use wire to cut and solder onto our parts and then solder onto the PCB. There's some simple tips for this. It's like a little more annoying to do or just more tedious to do than obviously just directly soldering onto the PCB. But here I have some 22 gauge stranded wire. I'm missing black, but normally I would do that for ground and then red for power. So I'll just use like yellow for ground or maybe blue. So I can just take a certain amount out and you can kind of roughly measure. I mean, you can just sort of eyeball it. So I know that I want to make this one a little bit bigger. So I'm gonna make it like that big and then I cut and now we can come and strip it. Now stranded wire, it's like a little more annoying to work with than solid wire. But yeah, in the case of something like this, there are these tiny little holes on it that you maybe can't see. Yeah, there are those little holes, and those are like a little too small for me to probably be able to fit this through. I can try, but the first step is we need to tin this wire. All right, this is Sam from the future. Unfortunately, this little tip I shot was like super out of focus like some other ones were. Apologies for that. But this one specifically, kind of wanted to show it off because I think it's a really helpful tip that saved me a lot of time, a lot of effort. So yeah, it's just on tinning your wire. I'm gonna just strip this wire first. So here's stranded wire. Like I mentioned, it's a bunch of just mini little wires within it. And we need to tin this, which is basically cover it in solder so that it kind of looks like those solid core ones and it's one just like continuous little pin looking thing. The reason for this is to just sort of prevent like fraying, it creates a better connection, and it will just be a lot easier to kind of stick into PCBs and other parts that we want to solder it to. So first step is that we just want to twist it so that it's kind of a nicer little point to work with. So there we go. Now I'm just going to clip this into my little hands right here. So before I learned this little tip, what I used to do is just kind of take the soldering iron on one side, and on the other side I just feed in solder and then kind of move them both together. And that works, but you'll notice you get a lot of sort of like clumps that you might have to cut off, or sometimes I'll just kind of cut the section I just soldered off and redo it, because then it won't fit in your PCB hole or anything. It's really annoying to work with. So this tip, basically, if I just get my clean soldering iron here, is basically we want to just put like a little dab of solder onto our tip here, and then just press that and hold against the end of the wire so that we can just directly feed solder onto it once it is warm enough. There we go. Took a second. There we go. And then boom. Now we're good. You'll see in the edge it kind of flared up, and that happens a lot, and whether it does or not, I just typically cut the end off like that, and then sometimes I will come in, or almost all the time, I'll come in with some needle nose pliers and just sort of flatten it out, because even once you cut with the wire cutters, it might kind of flare up on one side, and that can be annoying to work with. But yeah, it's just basically we want to feed the solder in once the wire heats up from the soldering iron there. That took like a little bit for me. Maybe I could have put more solder, not really sure. Sometimes having like a thicker soldering tip at the end, like your soldering iron tip, will help, but that creates a pretty perfect little tinned wire there. And yeah, there's like a name for what that is. I don't really remember offhand. Maybe I'll flash it on the screen here, but really helpful tip. I'm super glad I was taught that in school. So yeah, definitely recommend you tin your wires that way. And yeah, this one does fit right in the hole if I push like that. So there we go, that goes through, and then I can bend that a little bit and solder it. I might do it from this direction, but there we go. There is the power side of this jack soldered on. I can probably even cut this little excess. And later I will show you how to put heat sinks on this. It's something that again is not required. You can see some here. This is actually because I soldered two wires together, because I had to take this out and do some repairs, so I actually had to cut that there. But yeah, it's a way to just kind of keep the joints safe. It's really for heat stuff, but for this it doesn't really matter as much, but just a way to make sure that our little delicate soldering job stays. But yeah, I'm now going to go through and solder the wires on all the parts. It saves a little bit of time if you do each step at the same time. So before soldering this onto the PCB, I can do the foot switch and these two jacks, and that'll just save us a little time in the long run. Here are the jacks I'm going to use for this build. These are the ones that you might be using for yours. Once again, you need to kind of look and see which one is ground and which one is the signal. We had done this earlier, so hopefully you know by now, because you would have had to have used jacks if you used a breadboard, but typically the one with the kind of bigger arch is your tip, which is your signal. You can also look by actually looking inside. You'll typically see some sort of thing poke out, and that is the actual thing that's going to touch your tip of the jack. Like if I get a cable over here and plug it in, you can't really see it on the camera, but that part of that is touching the tip. It is sort of locked in there, and then we can follow that metal to see that that is this piece. Then there are sort of tinier jacks like this one where you can see that very much firsthand. So this is going to be our tip or our signal. So next thing I wanted to show you somewhat briefly, because this is an optional step, are those heat shrink things I was talking about. I'm going to do that just on this DC jack just for some extra protection. But you see here I have this set of heat shrink tubing, and you can see there's just all these colors with different sizes. And the point of this is to just sort of protect everything. You'll see this in some higher quality builds. And then what we do basically is take a heat gun, and after I put the tubing on, I can just put that under the heat gun and it will shrink. You can also use like a lighter or even a soldering iron sometimes. The heat gun is definitely the best way. The other ways you'll have to do a little bit more. You'll have to be a little bit more careful, but, and we can see that has already just completely hugged and wrapped around. And there you go. You can see it is now completely just hugging the pins for a nice secure connection that is definitely not coming undone. So now I got my foot switch, 2 audio jacks, and my DC jack all soldered together. So it's time to solder it onto the PCB. The only tip here is just to do that jack last, since you'll have to actually connect it up to the enclosure while the PCB sits outside of it. So it'd be annoying to do that first, but yeah, should be simple enough. Just make sure you kind of have the side picked out. Like here, all of my pins are sort of inside the daisy margins here. So instead of having the wires feed all the way under, I can just have it on top. But that's because my daisy, in this example, as I've said many times, is facing the face of it. Whereas for this build, I actually put the wires under it because that is less annoying than having it under the entire PCB. So yeah, I would solder it, make sure your daisy's not on there, and then when you fit the daisy on, you can kind of just move the wires out of the way. It's not that hard. So here, I just tinned the tip of this one audio jack right here. So I did that thing we did earlier, just rubbing some solder quickly over the wire, and then I was able to just push it right through the pins, bend them a bit, and solder them as we have with the normal parts. All right, so I soldered the 2 jacks and foot switch, so now it is time to do the DC jack. So like I said, you will need to, where's my hole? There's the hole for this one. So I need to feed it through this, pull it all the way through, and then you got to put the screw on. So I got to take these 2 legs. And this is something to just even note when you're soldering. This is the pins here you want to be pretty well kept so that it's easier for you to put this screw on. Because I've had times where I have had to kind of bend things, but this went on pretty well, and now you can just screw that in before you solder. All right, I got the jack all soldered, and now I'm ready to assemble. One other little tip, in case you run into troubles doing this, I know I have many times in my days of doing these pedals, especially just like, I play music while I solder. It's just like a kind of peaceful experience, but sometimes it makes you not pay attention, and I will solder like a ground wire into the signal and vice versa, and you'll have to desolder, and that definitely happens. I do recommend to get a proper solder sucker like this one. Like I used to have one of the ones that just came in those kits, like when my first soldering iron was like $20 for a kit, and it came with one in it, and I used to think they were just pretty unusable because the one I had was just bad. So I went and bought, this is Viraloy one, and this works great, and kind of just searching up more proper techniques on how to use it, and they're very fun to use. So recommend that. Hopefully you don't screw up anything too bad. So maybe on like a jack, if I soldered them the opposite way, I could just probably hold this while being very careful and put the soldering iron on the wire and maybe just use 2 fingers to pull it out. That would work quite well typically. You might find that when you put your tip to the solder joint that it doesn't actually liquefy. And the best tip there is you should actually put some solder on your soldering iron before you go there, because the solder will help it liquefy a lot better. You might need a higher temp. Sometimes desoldering, I'll need to turn the temperature up. I wouldn't do that first thing. I would just put solder on the tip, and that works for me like 90% of the time. If it is a wire, that is definitely best case scenario, because you can easily pull it off. Something like a pot would take a harder bit of desoldering because you have 3 pins and they would all need to be liquefied when you pull it out. Sometimes you could take like a longer wire that you lay against all 3 and you heat that up, and then they all liquefy and you can pull it. But yeah, there's a lot of ways. If you had to do something like the entire daisy, like say you didn't use headers for some reason, then again, you would probably need to lay some big thing across, because it would be pretty long, tedious process for you to just go through and desolder joint by joint. But yeah, hopefully you've put enough sort of fail safes so that you don't do anything too destructive and you get your pedal done. But yeah, I'm ready to put this pedal together and start testing it. And we did it. Here is our pedal completely done. This is the one that I've been building this episode, and this is the one from the course, obviously. This one I would just kind of push these little wires in and then just put the lid on. And this one is a little more compact and nicer, but yeah, these are completely done. So now we can kind of just test out and make sure everything works. I made this one to be sort of this daisy development box, because you can see here I actually put holes in for the boot and reset, and I have a little cutout for the micro USB. So I don't need to take the daisy out to program it at all, but you will need to. So you will have to kind of pop this out, and make sure when you do that, you don't rip it out from one side. The headers can bend, so you want to kind of equally pull from each side and pop that out so we can program it one last time. So you might have noticed by now this very odd looking laser engraving on my enclosure right here. And this is a very silly, stupid mistake I made when submitting my part to PCBWay. I custom ordered this part with the CNC machine services, and I had a little graphic that I wanted laser engraved on top of it. It's a cool way to just create a somewhat unique looking pedal that isn't just putting like a black graphic or something. It's this really light looking, nice texture sort of on top of it. But I was slightly confused by some directions, seeing as I've literally never in my life done anything CNC machine related. I've not touched this. That's why I've done some like basic 3D modeling with 3D printing, so I kind of understand that. But 3D printing and CNC machining are like almost the inverse of each other. You know, one's like creating it bottom to top. CNC machining is like all these axes rotating. I don't even know. But I saw that it said we needed multiple files for the sort of top graphic, one that is the graphic itself, and then another which is kind of showing them the area. Because the thing about PCBWay is this is like a pretty heavily automated site. You know, they aren't having all these people look through everything. You need your initial review, and then I assume it's just sent off to the machines. So I sent two graphics. One was my .ai file with my Adobe Illustrator thing, and the other was a DXF file. And that had just all of the little holes laid out, and then it said engraving area. And the point was I wanted to say like, hey, this is the side, this is the orientation that I want to be engraved. But I found out that first off, those probably should have just been combined. I could have just showed the holes on the graphic and they would have understood. But also I believe it is something about the fact that I had uploaded this file first and then the machine just sees that one and it goes. So when it was initially reviewed by a person, it was approved, but then eventually the machine just was given this one file. But I told them about this and they reached out, very apologetic, even though it was very much my fault, and they offered to send me a new one. I said no, because I don't want to just have to throw away this nice parts, and I think it's honestly kind of funny. But just a good thing to note when using any service like this, that you should triple check your work like we did earlier and just make sure of everything and make sure you understand it all. Luckily, when you're using a service like PCBWay, they were extremely kind about it. They didn't, even when I reached out, they didn't know that this was a sponsored thing or anything. I just reached out on my own and they were extremely kind about it. So you know you're in good hands ordering with them, but you do want to make sure that you get the right things to upload so you don't make the mistake that I did. Well, guys, we did it. We've made a guitar pedal, a custom, fully built pedal. The day has left us after hours of work. Our desks are all very dirty, but you know what we have over people with clean desks? We have a guitar pedal, and that's what matters. But unfortunately, just because you soldered everything together, it does not mean it's gonna work. So now you have the amazing process of just testing every single knob to make sure it works. As I said, hopefully by now you have taken your daisy out and you gotta put some code on it. But I've held your hand this entire course by talking and going on way too long of tangents. So I'm going to hope that by now you can do this next part on your own. Obviously, up to this point, you may not have actually written code specific for the pin layout that you made your PCB. So now is your time to do so. You should be able to go and take that passcode that we wrote and just change the defines at the top and then flash that. But also on top of those changes with the foot switches, we now have an LED, which we did not use earlier. And that's something that I'm also going to leave to you. My helpful hint is to search up the GPIO on the DaisyC documentation. That is how you should initialize your LED. But if you get really stuck, I do have all the code available for this pedal specifically and the chorus pedal, but built for my PCB in the GitHub repo in the description. Some recommendations though for testing things is before like throwing something like your chorus or like something you wrote recently onto there, because maybe the problem would be actually with your code, you should throw something really simple that you can just one by one test each knob. What I typically do is just use the Daisy oscillator class, and then I map each knob to just the frequency of the oscillator because it's super audible to tell, and then just put the bypass to turning it on or off, and then you can join up the LED with the bypass and you can just test everything. You could have literally every single knob mapped to frequency and they all are just changing it. I think that's a really easy first way to test. Now, what happens if you turn a knob and it doesn't work or you get unexpected results? Well, first thing to do is double check your code, because that's the easier thing to debug, obviously. But it depends on what the issue is. If your knobs are going the opposite way as what you expected, then maybe you got your ground and powers mixed up in your PCB, or somehow you soldered it backwards. All you got to do is invert the data coming in your code. That's pretty easy. Foot switch, since that's not polarized, you should know that your wires are good, but you should also just double check your wiring of the PCB itself, because maybe you messed up a while ago in KiCad, so you should double check that. But first thing would just be to make sure you have your pins correct, because if just literally nothing, no data is coming from it, then that would be my first guess, is that you maybe just read which one wrong and you just mapped them to a different thing. But hopefully it works, you know, especially a pedal like this, it's only 3 knobs, so it should be simple enough. But yeah, if you're just like doing somebody else's design, like say you maybe just did this one, then obviously I would go to blame your code or the soldering first. The answer is probably not the PCB, but it can be. I mean, like I mentioned earlier, there can be internal things in your PCB that get messed up in shipping or something, but it's pretty rare. So I would blame yourself first. So some of you out there might be confused or let down that I went a whole video on how to build a pedal and I have not yet mentioned impedance or Ohm's law or buffers or any of that stuff. And I do have a reason for it. Hopefully you might agree that it was justified. If not, I am sorry. I might make a more in-depth tutorial on that in the future, but this was for complete beginners. And I figured if you could make an entire pedal that is unique and cool and sounds good and not need to dive into that stuff yet, then that is a positive. But it does mean that we have a few steps to go before we get to professional level or even like advanced beginner, because obviously what I taught here was more just like a little bit of everything on the stages, or mostly about just the kind of like enclosure manufacturing side, because I find that to just be like the most fun part of it. You know, making the art, figuring out how you want your knobs laid out, I think is a really satisfying way to start and get that inspiration before being overwhelmed with the world of electrical engineering. As somebody like me who in no way has an electrical engineering background, I took some classes in college, but yeah, I went to music school. So I just wanted to make guitar pedals at the end of the day. But for those wondering, impedance is an issue with the Daisy Seed. This is not something that you want to just avoid forever. So is impedance an issue with the Daisy Seed and guitar pedals? Yes. But was it a big enough issue that I thought that you should not make a pedal at all until you have it figured out? No. Technically, the Daisy Seed does want a low impedance input, whereas the guitar gives out a high one. What this means is you can basically expect some tone loss. Just certain voltages across the frequency spectrum will be lost due to this. But in my experience, it wasn't great enough that I don't think it's like not worth it to make a pedal without a buffer. A buffer is how we fix this impedance issues. If you are completely unfamiliar with these terms and these things, I would just start with learning Ohm's law, which kind of will explain a lot of the ratios of this stuff, because impedance is just dealing with that current and voltage and just kind of how they all relate, and it will help build your understanding. But you'll hear impedance described as AC resistance, or it's used with the letter Z. So a lot of like techniques and the foundations you learn from V equals IR will sort of apply to impedance and help you get that understanding of just like what is trying to draw power from what. But basically when we play our guitar that is generating voltage, typically I think in like the millivolts or something, our guitar, like it's not super high, maybe some pickups could get upwards of like half a volt, I think. But yeah, so we're sending that AC signal into the Daisy, and we just want a way for the two circuits to kind of not interfere with each other. We don't want one step to sort of step on the next step or draw power or current or whatever when we don't want it to. So what we do is we put a buffer in the middle of it. And these are like pretty simple circuits to understand. I think they just are kind of like confusing at first to kind of know where to look. But the two most common ways to make buffer circuits in pedals are typically with JFETs, which are a type of transistor, or operational amplifiers, also called op amps. Already with that, you can honestly go and just Google like op amp buffer circuit, or you can go on sites like Electro Smash, which will kind of break down famous pedals and you can see their buffer stage. But that doesn't mean that everything will apply one-to-one. There might be plenty of extra stuff that you don't need there. So the basics with specifically an op amp, because I've done the most with that, are what are called unity gain op amps, which are just like a certain configuration within an op amp. Because what op amps typically do is amplify your signal. There's this little equation with this variable A, which is like in an ideal scenario, this infinite number that is gonna like slam your audio up and then kind of clip it at what the power rails that you feed it are. Doesn't matter, but basically we want it to just match the exact voltage on the inputs and the outputs. So you do this way, if you Google it, I'll have maybe a photo here where you can route it'll look like a little negative that's considered the inverting input, and that'll just kind of be looping forward and connected with your output. And that basically just means that it will try and match the voltage at your input there with your output. And the effect of that is basically that coming into it can be a high impedance signal and it will give out a low impedance signal. And it kind of is just as simple as that, but there's a few things we should consider when designing a circuit with this. First is that for most of these op amps, you'll be using these pedals. They are what are called single supply op amps, meaning that they can't handle negative signals. So we have to do what's called bias the signal before it goes into the op amp. So if you imagine your signal voltage that is modulating, and it is modulating say like 50 millivolts to negative 50 millivolts, meaning it is going around zero, then you have all those negatives. So we just want to offset that by a certain amount so that it is still going up and down, but it's not going into negatives. And luckily this is pretty simple to do, but there's like a lot of different ways to do it. One simple way is that we can just take our 9 volts that comes from just like our DC jack we plug in, and we could just make a little voltage divider with just like 2 resistors. So I can take that 9 volt thing and put 2, like say 1 million ohm resistors in series. So after that first resistor, we'll get half of the voltage we're sending into this. So if it's 9 volts, we'll get 4.5, and then you have another resistor of the exact same value that goes to ground. So that'll just create your bias point, as they call it. You'll hear people call this like virtual ground or VREF in schematics. So that's something that can be helpful if you're looking at other schematics. You'll see, yeah, V ground, VREF, and that's typically referring to this bias point. So the voltage divider thing I just explained worked, but that won't be super stable. The voltage could fluctuate, so you'll want resistors that have a 1%, whatever that's called, whatever the word is, I'm forgetting. And then with a circuit like that, you also might see somebody throw a capacitor from that the V bias point to ground to just smooth that out and help with those kind of fluctuations that I described. But a more professional way to do it is that you could actually buffer that V bias, because if you kind of have a rough understanding of Ohm's law, another issue with the voltage divider that is true of all these sort of simple resistor series voltage dividers is that if at that V bias point we started adding other circuits or other things that can draw power, now that voltage there is actually going to change. So that 4.5 could turn into 4 or something, or just go to a different value that we don't want. So another more professional option is to actually buffer the voltage that we would want at the V bias, so that it can have low impedance, so that when more things add on to it, it won't fluctuate that point, which is good, and it will just be more stable. So yeah, I know I'm throwing a lot of random stuff at you, but these are kind of things that if you don't know where to start, just terms to maybe search up. You don't have to dive into this huge electrical engineering course to just make simple schematics for your guitar pedal. There's simple things like high pass filters, which do have this little equation right here, 1 divided by 2 pi, and then the resistor value in ohms, then your capacitor in farads. It's pretty simple to find. You'll see that's just done where you have a capacitor with a resistor going to ground, and you'll see this a lot maybe if you go on those websites where you study other pedals, and you could just plug those values into that equation to kind of see what frequency that cutoff filter is at. So that's really handy. Another thing with the start of the buffer circuits is you'll typically see a capacitor just at the very start of it. This is typically your AC coupling capacitor. That's because capacitors will block DC signal, so it can just help with that AC signal coming in from your guitar. It's just, there are all these little standards that you'll slowly learn, all these little building blocks. You don't have to understand like the exact atomic structure of what's happening in a capacitor to just understand how to use these little parts in your circuits. There's other really common parts, like after the DC jack, you'll commonly see a diode, which is just helping block those like reverse polarity protection. You'll typically see what are called Schottky diodes, the like 1N58 something, I don't know, I'll put it here, but that's like a super common one you'll see. That has like littler voltage drop than some other diodes will have, so it'll just keep your signal better. And then you'll commonly see lots of capacitors coming from your power to ground. These are all just smoothing things, or things for like RF, like just radio frequency, all this stuff. But yeah, a lot of times just you could steal them and throw them on a breadboard and then learn how to put them on a PCB. But the reason I didn't end up throwing all of this is, one, I'm like not a professional at this. All the other stuff I taught in this course was like super simple stuff. It's just kind of hard to piece together, so I felt confident teaching it. Whereas this stuff is a lot more complicated, and I don't have that electrical engineering background. But also, since the point of the course is to create your own unique pedal, there's a lot of PCB design concerns that come in once we're adding all of these different components that are honestly probably the trickiest part to deal with, at least for me. Like, understanding some of this buffer stuff isn't that hard, but you'll have to really Google and search for all the design considerations that you need when making PCBs. And I know for a lot of my first ones, I was pretty much just copying some schematics I found online. PCB would come and it would just be super noisy, way noisier than if I just didn't have the buffer, because I had no idea what I was doing. I was just randomly putting everything together, and I thought it like looked pretty or something. But yeah, it takes some extra steps for sure, but it would be worth it in the end. I will also just say, if you make this pedal from this course with no buffer, but you're using it on a pedal board, a lot of times you're probably fine, because a lot of pedals have output buffers that are like pretty much protecting that next stage. So as long as your pedal that you just made isn't the first in your pedal board lineup, then you're probably not really having that much tone loss at all. So it's not like a huge deal to worry about, but it is something to note. And if you ever really want to sell this stuff, then it is definitely the next step in your journey. Besides, obviously, if you are going into programming. All right, I don't even know where I was in this, because I noticed the camera just wasn't focusing at all. So if it was unfocused for a lot of that, I'm sorry. It is right now. Okay, lock onto my eyes. All right, moral of the story, V equals IR, that's your next step. Impedance, that's your next step. You got this. Simple little high pass filters, op amps, buffers. Focus. But enough of my rambling. We're done. If you've made it this far in the course and maybe have a pedal by the end of it, you have my sincere thanks. I would love to see what you build, or more than anything, I'd love to hear the music you make, because that's really all this is about. You know, I made this course not to teach crazy technical people about anything, but I think that for just like a random guitar player or a random musician or anything, that this stuff should not be gate kept, and it's actually a lot simpler than people think to just get an end result. You know, obviously all of the fields I covered here are huge. You know, you could have entire careers just studying this and stuff of each individual thing, but to just do and make cool pedals, you don't need years and years and years of experience. You just need a little course. So yeah, if you have any more questions, feel free to reach out to me at my email or just comment down below. The GitHub repo is available with all the code from this course and some extra resources. And yeah, this took a lot of time. I would appreciate a subscribe. All my videos are going to be pretty related to this, and if you have the backbone of knowing all this, then you might get more appreciation of some of the projects that I have coming. I'm going to do a lot of stuff involving the Daisy and PCBs and everything. So if you like this, then you'll enjoy in the future. I'm not going to be mainly tutorials. I'm hopefully just going to post more quick fun stuff showing projects I build, and then kind of obviously telling you how to do it. And I'll always have documentation for my little projects. So subscribe if you want more of that, hit like, all that stuff, and I will see you soon. Thank you.